Welcome to the Explainer, everyone. Have you ever actually stopped to look at one of those random grids of static black and white squares we scan practically every single day? Whether we're looking at a restaurant menu, paying for coffee, or pulling up a boarding pass, QR codes are literally everywhere. But, to the human eye, they just look like a bunch of digital static, right? Well, today, we're going to completely demystify that little square. We're going to break down exactly how it works, piece by piece, and we'll do it in plain, simple words. Okay, let's dive right into this.
So here's our roadmap for today. First, beyond the barcode. Second, anatomy of a QR code. Third, translating squares. Fourth, our secret sauce, error correction. And finally, number 5, how your camera scans it. Let's get to it.
All right, Section 1, Beyond the Barcode.
To really get why the QR code is so magical, we first kind of have to look at the massive leap in technology it represents over older systems. Think about the traditional barcode. You definitely know this one. It's on every single box of cereal or can of soup at the grocery store. Now, a traditional barcode is strictly one-dimensional. The scanner only reads it in one direction, horizontally, right across those vertical black lines. And because it only reads one way, it can really only hold a tiny string of numbers. Now let's compare that to the QR code. QR actually stands for quick response, by the way, and it's a two-dimensional barcode. Instead of just reading side to side, a QR code is read both horizontally and vertically. By tapping into that second dimension, it opens up this massive grid, allowing it to hold up to several hundred times more data than a standard barcode. It's a total game changer.
Moving right along to Section 2, Anatomy of a QR code.
Okay, so we're going to freeze the code and dissect it piece by piece, almost like it's a living machine. Because it turns out, your camera doesn't just look at the whole messy blob at once. Nope, it looks for very specific structural landmarks. Let's start with the most obvious feature here, those 3 big squares located in the top left, top right, and bottom left corners. These are called finder patterns, or position detection squares. You can think of them as giant "you are here" signs for your camera. In simple words, they tell the scanner exactly where the boundaries of the code are, and, crucially, which way is up. This is exactly why you can scan a QR code upside down, sideways, or even diagonally, and it still works perfectly every single time. The camera spots these 3 squares first and instantly knows how the image is oriented.
Building on that, take a look down near the bottom right corner. See that smaller square? That right there is the alignment pattern. Think of this little guy as the anchor. Let's say the QR code is printed on a curved surface, like, say, a coffee cup or a crumpled up poster. Or maybe you're scanning it from a really weird, sharp angle. This single reference point helps the scanner calculate that distortion. It ensures it can read the code accurately, no matter how warped it might look out in the real world.
Next up, look really closely at the space between those 3 big corner squares. You'll probably notice dashed lines of alternating black and white dots connecting them, almost like a little road. Well, this is the tining pattern. These rows and columns essentially act like a ruler. They help the scanner figure out the exact size of the entire data matrix grid. It basically tells your phone, hey, expect exactly this many rows and this many columns, so the camera knows precisely how to slice up the image.
Now, tucked right next to those big finder patterns are these tiny, specific sections of squares called the version and format information. This is essentially the bossy instruction manual for the scanner. You see, before your phone is even allowed to try and read the main message, these little blocks tell it what type of data is actually stored inside. Is it going to be a website URL, a simple text message, maybe a digital contact card? It also tells the scanner exactly what version of QR code is being used, which dictates the overall size of the grid.
And finally, for our anatomy lesson, we have the quiet zone. This is that solid white border surrounding the entire QR code. Now, it might just look like blank, wasted space, but it's incredibly important. This solid white border provides crucial isolation. It acts as a buffer zone so the scanner doesn't get all confused by surrounding graphics or text or even the color of the table the menu is sitting on. It simply says to the scanner, hey, everything inside this white box is the code. Just ignore the rest.
All right, Section 3, Translating squares into data.
Now we're moving into the real brain of the QR code. The remaining space inside the grid is filled with smaller black and white squares, and these are called data modules. So how does this jumble actually become a website? Well, it all comes down to binary language. To a computer, a white square simply represents a 0, and a black square represents a 1. It's really just a long string of on and off switches. But there's a catch. If your message accidentally created a giant block of all white or all black squares, the scanner would get totally lost. So, to fix this, they use something called data masking. In simple terms, data masking is a mathematical formula that acts kind of like a blender. It scrambles the pixels to distribute the black and white squares evenly across the whole grid, completely avoiding any confusing blank spots. When your scanner reads the code, it automatically reverses this mask to reveal the true binary message hidden underneath. Pretty clever, right?
Which brings us to Section 4, Secret Sauce, Error Correction.
Have you ever scanned a QR code that was partially ripped off a wall or maybe had a giant coffee stain covering half of it and it still magically worked? Yeah, that is not an accident. That is all thanks to baked-in backups, known as Reed-Solomon error correction. This is what makes these codes nearly indestructible. When a QR code is generated, redundant copies of the data are baked directly into the layout. Depending on the settings chosen when creating the code, it can recover from varying levels of damage. Level L can survive up to 7% damage. Level Q can survive up to 25%, but Level H allows a whopping 30% damage recovery. Now, what's really interesting about this slide is that this is explicitly why you see companies plastering giant logos right in the middle of their QR codes. They purposely use Level H, knowing full well they're destroying a chunk of the code with their logo because the mathematical algorithm simply heals itself. It pulls the missing data from the remaining intact squares. I mean, it is an absolutely brilliant design.
And lastly, Section 5, how your camera scans it.
Okay, we've dissected all the anatomical parts, we understand the binary translation, and we know all about the error correction. Now, let's put all of these pieces into motion for a real-time scan. When you hold your phone over a menu, 4 things happen in literally a fraction of a second. Step 1 is capture. You point your camera at the grid. Step 2 is orientation. The software instantly searches for those 3 big corner finder patterns to orient the image so it knows what's up and down. Step 3 is normalization. The app uses the smaller alignment square and the timing dash lines to digitally flatten out any tilting, warping, or curved surfaces. And finally, Step 4 is decoding. The scanner reads the tiny version info block, strips away the scramble of the mask pattern, converts all those black and white modules back into binary code, the zeros and ones, and translates that binary into human-readable text, popping up a web link right there on your screen. So the absolute craziest part is that this complex, multi-step ballet of geometry and math happens flawlessly in the literal blink of an eye.
So, you now understand the incredibly complex language of the squares you scan every single day. But knowing how seamlessly your phone strips away the mask and translates those black and white squares into actionable data, well, it leaves us with one final thought. Since you have absolutely no way of reading that binary with your own eyes until it's already processed by your device, are you curious about the security aspects of scanning them? Just something to think about the next time you point your camera at a random square on the street. Thanks so much for joining me on this explainer, and keep learning.